Hello, Mr. Josephs here. I'm going to read to you some of the information from this lab to get us started. So let's look at the introduction. Crime scene investigators obtain many different types of evidence at a crime scene, including samples of fibers. In this experiment, you will identify the type of fibers left at a crime scene by performing a series of 3 tests on the obtained evidence. So, we're going to look at some physical and chemical properties, and some chemical bonding, and some forensics. Okay, here we go. So the background. Fibers are the smallest component of a textile material. They are used to form fabric, rope, carpets, etc. Fibers gathered as evidence at a crime scene may arise from numerous scenarios. They may be transferred via personal contact between suspect and victim, and they can also be transferred to other items at the crime scene, such as furniture, weapons, or flooring, due to physical struggle. Fibers may be analyzed by visual inspection based on their appearance and comparison with known samples. Identifying fibers based on appearance requires the use of a microscope to view minuscule details. Natural fibers are easier to distinguish under a microscope. Synthetic, man-made fibers are traditionally less descriptive under a microscope because they can consist of practically any strand diameter or color. Synthetic or man-made fibers typically have more uniform diameter and appearance than natural fibers. Therefore, microscope analysis is not the main determining test used to identify fibers, but it can be helpful as an ancillary test. In most cases, fibers are analyzed based on their physical and chemical properties. The burn test is a primary identification technique used to determine fiber identity. When held near a flame, different fibers will exhibit different behaviors. Some will begin to melt, and others will twist or curl up. When ignited, they will also react differently. Some fibers burn slowly, others burn quickly. Some will melt and drop off before the flame reaches the rest of the fiber. Odor is also a powerful tool in identifying an unknown burnt fiber. If the smell is similar to that of burning hair, the fiber is most likely silk or wool. If you don't know what burning hair smells like, pull a piece out and burn it and see what it smells like. It's not fun. If the smell is similar to burning paper or burning wood, the fiber is probably cotton, rayon, or linen. Do not burn any pieces of paper, please. If the fiber melts, it's likely a synthetic material such as nylon or polyester. Fabrics are also identified based on how chemical dyes bond to them. How well a dye is attracted to a piece of cloth, its affinity, depends on both the fabric and the dye molecules. Chemistry thus plays an important role in how and why dyes work. Dyes are water-soluble compounds that are charged. Animal fibers, such as wool, which are composed of protein molecules, are usually easier to dye than plant fibers, such as cotton, which are composed of cellulose. Wood fibers have many dye sites, groups of molecules that have positive or negative charge, and thus attract the charged dye molecules. Dye sites may be ionic, that is, fully charged, or polar, that is, partially charged. Let me read that sentence again. Dye sites may be ionic, that is, fully charged, or polar, that is, partially charged. In general, dyes have greater affinity for natural fibers like wool and cotton than for most synthetic fabrics. Many synthetic fabrics, such as acrylic and polyester, are hydrophobic, water-fearing, and have fewer dye sites, making them more difficult to dye. One exception is nylon, the first completely synthetic fiber developed in the 1930s from petrochemicals. Nylon dyes more easily than many other synthetic fabrics because it has polar dye sites. Acetate, another synthetic fiber, is chemically similar to cotton but has fewer dye sites. So here is the experimental purpose. The purpose of this experiment is to examine 6 different types of fibers using a burn test and dye analysis to observe their unique physical and chemical properties. And you have some pre-lab questions and some safety precautions that we will take. For our lab, we are going to use the lab data for the dyeing portion, but you will be able to burn the different fabrics that are used in this lab. One thing that I'd like to say, part B, it says burn analysis, but make sure you're very careful for the first part where you just put it over the flame. Let's see, you're just gonna put it over the heat, but not within the flame. You don't want to burn it yet. You just want to see what it's like. And then in the data section, you're observing what's happening when it's heated. Then, only then after that, do you put it into the flame and see what happens when it's ignited or catches fire. Now, some fibers burn very quickly, and you might have to redo that particular fiber over again. So be patient and retest if you need to. So those are the first two tests that you're going to be doing. Notice that in the beginning it said that you're doing 3 tests to obtain evidence, or 3 tests on the obtained evidence. The obtained evidence is this piece of cloth, six pieces of cloth. The second thing you're going to do is, like I said, ignite it, and then we're going to have each of these be dyed and see how well they dye. If they have a great affinity, they're going to dye very easily. If they don't, then they will not dye very easily, and you're going to use the lab data for that. The lab data for the other one is in there as well, so you can take a look at that if you want to. But you're going to be burning these yourself. And then after you're done, there are post-lab questions that you should answer. And that's it. Go ahead and have some fun.